Good morning, all. Now, today we are going to study about our chapter 4 of NCRT book, that is about the determinants. Now, in our previous video, uh, I have explained you about the introduction part and the area of triangle. Now, today we will be covering exercise 4.4. Now, this exercise 4.4, 4.5, and 4.6 all are related to each other. I have written all these exercises in the descending order, that is, starting from the last. Now, our exercise 4.6 covers the solution of linear equations using the matrix method. 4.5 covers the inverse of a matrix, although we have already studied, but this is through a different method. And this exercise will also cover the adjoint of a matrix. Then in exercise 4.4, we have cofactors and the minors. Now, all this text written here is deliberately written in the reverse order. The reason being, from this exercise, we will first find minors, then we can find the cofactors. After these two are done, we can find the adjoint of a matrix. Through this adjoint, we can find the inverse of a matrix, and through this inverse, it will be very easy for the solution of linear equations. Let me explain it in a better way. Now, this is the portion that we have covered in the last slide. Now, see, if I talk of the reverse order, the solution of linear equations. The solution of the linear equations. It follows the formula x is equal to A inverse B. It follows the formula x is equal to A inverse B. Means this solution requires A inverse multiplied by B. Now A inverse, as we all know, that this is the inverse of a matrix. Inverse of a matrix. Now using this inverse of a matrix, it can be found out by this particular formula, which will say A inverse is equal to 1 upon A mod into adjoint A. Now comes another one term, that is adjoint A. Therefore, the adjoint of a matrix. Now adjoint of a matrix can be found out by the cofactors matrix and its transpose. Adjoint A will be the cofactors matrix and its transpose. Now, what is this cofactors matrix? Cofactors matrix is something like this. Now, if you see this A11, A12 are not written in small letters. When we write this in small letters, we talk of elements. When we write in capital letters, we talk of the cofactors. Now another new term has came, that is a cofactor. What do you mean by a cofactor? Cofactors will be mij multiplied by minus 1 to the power of I plus j. Now again another new term is, that is mij, which will say about the minus, which is represented by this. Now this slide becomes very important in order to learn the correct sequence. If I go in the reverse order, means if I need to find this the value of x, which will be covered in three different exercises, I will start with this minus part. What do you mean by minus? And from this minus, how can we find the cofactors? From these cofactors, how can we find the cofactors matrix? From this cofactors matrix, how can we find the adjoint A? From this adjoint A, how can I find the value of A inverse? And from this A inverse, how can I find the value of any unknown variable x? This is the sequence of the three exercises which are left in this chapter. I repeat, this is very, very, very important. I repeat my point. I'll say, first of all, we have to find minors. From this minors, we will find cofactors. From these cofactors, we will find this cofactor matrix. From the cofactor matrix, we will find adjoint A. From this adjoint A, we will find A inverse. And from this A inverse, we will find the unknown variable X. In this particular video, we are going to cover minors and cofactors. Now, how to find the minors? Remember, whenever it is written in small letters, we mean elements. Means if I have taken an example of this matrix A as 1, 2, 3 and 8, this A11 component is this is A12, this is A21 and this is A22. Remember, all are written in small letters. Whenever we talk of small letters, we talk of the respective elements. Whenever we write this as capital letters, it means we are writing their cofactors. Now, the number of elements will be equal to the number of minors. It means every element has its minor. A11 will be having its minor, A12 will be having its minor, A21 will be having its minor, and A22 will also be having its minor. If it is a 3 by 3 matrix, we will have 9 different minors. They will be represented by M11, M12, M21 and M22. Now, how to find the minors? Let me have a pen here. Now, the minors. The first is Mij. They are always represented by Mij, where I will represent the number of row and J will represent the number of column. Means if we talk of this, the value of I is 2 and the value of J is 1. The first step is to find M11, M11. How to find the minors? If I talk of this element, ignore this particular column and ignore this particular row. You will be left out with one element which will be its minor. Similarly, for M12. Now for this M12, I am talking of this. I am talking of this particular element. Ignore this row and ignore this column. We will be left with 3. Next, after this, what we have is M21. Now, if we talk of M21 means of this element, what we will do is we will ignore this column and we will ignore this row. The left out element will be minor. Similarly, for M22 means for this element, we will ignore this row and we will ignore this column. We will have the minors as 1. Now I have explained the same concept in this matrix also. Please try to focus. M11, ignoring this column, ignoring this row, we will be left with this. M12, ignore this column and ignore this row. We will be left with minus 7. Next, M21. M21 means this element. Therefore, ignore this column and ignore this row. We will be left with 5. Last, for this element, ignore this column and ignore this row. We will be left with minus 3. This is the way we have to find the minors. Remember, in order to find the solution for linear equations, the first step is to find minors. After this, the next step comes the value of cofactors, and the cofactors are defined by this particular formula where Mij multiplied by minus 1 to the power of I plus j. I am taking the previous example only where I have taken The matrix A has 1, 2, 3 and 8, and these are the allocations, means this is A11, this is A12, this is A21 and this is A22. In order to find cofactors, we have to first find minors. As explained, minors will be found out by the same method, ignoring. If I need to find this minor, ignoring this column and ignoring this row, you will get the minor. Now comes the value of cofactor. Now see this A11. I explained you, if this is small, we will be talking of this particular value, and if it is capital like this, it means now we are expressing their cofactors. And the formula says Mij. Mij means minor of this particular M11. Now M11 we have calculated as 8, therefore written 8 multiply by minus 1 to the power of I plus j, minus 1 to the power of I plus j, where this is I and this is j. Solve it, we will get minus 1 to the power of 2, which will give you 1. 1 into 8 will give you 8. Therefore, minor for this particular element is this, and cofactor for this element is this. I hope it is clear. I hope that you all are getting what I am trying to say. Now, next we have M12. M12 is this element, means ignoring this column and ignoring this row, we will get the value as 1. Oops, sorry. This one. Ignoring this column and ignoring this row, we will get the element as 3. Now, this is M12. In order to find the cofactor, this is the formula that we have to use. Mij. Mij means M12 because this element is 1, 2, right? M12. M12 is 3. Written here 3. Multiply by minus 1 to the power of I plus j. Minus 1 to the power of this is I and this is j. Therefore, 1 plus 2, you will get the value as 3. Similarly, for M21 we can also find using the same method, and for M22 also we can find the same method. There is a small correction. This will not be 1, 1. This will be 2, 2. Now, what we have studied is, we have done for the minors, we have done for the cofactors. Remember, it is just a 2 by 2 matrix. For a 3 by 3 matrix, we will be covering the same in our next video. I hope you all have understood. Thanks. Stay healthy and stay safe.